Okay, the homework, 37 to 75 odd. Okay, we start out with the absolute value of negative 1/2 b minus 2, so equals 10. So we're going to write negative 1/2 b minus 2 equals negative 10. We're going to make two equations. And we're going to write both equations without the absolute value symbol. In one equation, we simply write the original equation, 1/2 b minus 2 equals 10, the exact same way as the original. We write one of the equations exactly the same as the original equation without the absolute value vertical bars. The other equation, we're going to write the left side without the vertical bars, but the right side will be negated. Okay, so we have two equations for two answers because there will be two solutions to this absolute value equation. There's always two. So we got minus 1/2 b minus 2 equals negative 10, and minus 1/2 b minus 2 equals 10. So let's do the negative 10 first. So the first reciprocal operation, we add 2 to both sides, and it leaves us with negative 1/2 b equals negative 8. Multiply both sides by negative 2 over 1. The multiplicative inverse of negative 1/2 is negative 2 over 1. So that gives us 1b on the left, and we get negative 8 times negative 2, which is 16 on the right. So b equals 16, and then I plug it in and I check it, and it turns out I get the absolute value of negative 10 equals 10, which is true. Okay, now let's do negative 1/2 b minus 2 equals 10. Add 2 to both sides. Get negative 1/2 b equals 12. Multiply both sides by the multiplicative inverse. And then we get b equals negative 24. Then I plug in negative 24, and I get 10 equals 10. Okay, two solutions are negative 24 and 10. Or, I'm sorry, 16. I got the wrong thing here. That should be 16, not 10. Okay. Anyway, so we're supposed to make the graph with two solutions. Just 2 points on the number line. 39. Absolute value of 5f minus 3 equals 12. Okay? Drop the absolute value bars. 5f minus 3 equals 12. And we get f equals 3. Plug it in to check it, and so it checks out okay. And then 5f minus 3 equals negative 12. And we're going to end up with negative 9/5. Okay. Add 3 to both sides. 5f equals negative 9. Divide both sides by 5. Again, the multiplicative inverse of 5 is 1/5. So f equals negative 9 over 5. And then I check it. You can see the check here. I plug in negative 9 over 5 times 5 minus 3. I get negative absolute value of negative 12 equals 12. Okay, so here's the two answers, negative 9/5 and 12. 41. Okay, we went over this in school, in class. So for the first time, we do not have the absolute value function isolated. So in other words, we want the absolute value function all by itself, 1 times the absolute value function. That's it, and nothing added or subtracted or divided or multiplying it. So the first thing we got to do, we do reciprocal operations in reverse. So the first thing we're going to do is subtract 4 from both sides to get rid of that 4. So we use the additive inverse, 4 minus 4 equals 10 minus 4. So now we're left with negative 3 absolute value q equals 6. Well, we want 1 absolute value q, not negative 3 absolute value q. So we divide both sides by negative 3, the multiplicative inverse, and we get absolute value q equals negative 2. Now, the absolute value function must have an output that is at least 0. It must be greater than or equal to 0. It can equal 0, but it cannot be negative. So when you have the absolute value of q equals negative 2, then there is absolutely, positively, no value of q that will make this equation true. There are no solutions. 43. Absolute value of x. Here, let's see. Let's go to the problem. I know. Okay. All right, sense making. All right, we touched on this in class, but let's go through it. A 4x400 relay race. Okay, 4 runners take turns running 400 meters. And 400 meters is 1 lap around the track. So each runner goes 100 meters. And they have a little thing called a baton that they pass off to each other. So All right, so we expect that the speed of the individual runners, add it all up, is going to be the smaller, the two ranges, least, slowest, and fastest times for these four runners. Okay, so we're told the first runner runs the first leg in 52 seconds, plus or minus 2. So when we see plus or minus, okay, that is the margin of error, okay? And so the general model that we're using here, there's going to be a number of different ways to express this model conceptually, but let's take margin of error, and that's what this 2 is, this plus or minus 2, equals the absolute value of the actual running time, let's call that x, minus the average time. Okay, so this runner averages 52 seconds, but with a variation of 2. So the equation for this, the absolute value, is going to be x minus 52 equals 2. It's because we're looking for the difference between the actual time and the average time. So what is going to be the spread of the running times for this runner? So we get x minus 52 equals 2. We add 52 to both sides. We get x equals 54. And then we're going to make the other equation, x minus 52 equals negative 2. We add 52 to both sides. We get 52 plus negative 2, and that's 50. So the times for this runner are going to vary from 50 to 54 seconds. Okay? Now, B. Let's make an equation for B. Now, for B, the margin of error is 1, plus or minus 1 second. See, plus or minus, they're talking about margin of error. Okay? His average time, or hers, is 53 seconds. So the equation is going to be actual time minus the average equals the margin of error. So x, we're going to make that the actual time, because no two times are exactly alike. They're never going to run the race exactly the same two times. So the absolute value of x minus 53 equals 1. So we make the two equations. X minus 53 equals 1. Add 53 to both sides, and you get 54. X minus 53 equals negative 1. And then add 53 to both sides. Negative 1 plus 53 is 52. So this runner is going to, this runner's spread is from 52 to 54 seconds. Last runner averages 50.5 seconds. Okay, with a margin of error of 1.5, or plus or minus. Okay, so the equation is x minus 50.5 equals 1.5. So we make the first equation, drop the absolute value bars, x minus 50.5 equals 1.5. Add 50.5 to both sides, x equals 52. Second equation, x minus 50.5 equals negative 1.5. Add 50.5 to both sides, so you get 50.5 minus 1.5, and you're going to get 49. So the spread of times for the fourth runner, remember there's two runners that have this spread here, two runners. Then for the fourth, the runner running the fourth leg is going to be from 49 to 52 seconds. Okay, so how do you find, so part C is what are the team's fastest and slowest times? Okay, so, well, the fastest time for the first runner is 50 seconds. For the next two runners, it's 52 and 52. And for the fourth runner, it's 49 seconds. For a total of 203 seconds being the fastest time. Now, the slowest time for the first runner is 54 seconds. And the slowest time for the next two runners is also 54 seconds. And the slowest time for the fourth runner is 52 seconds. So, for a total of 214 seconds. So we expect their times to vary between 203 and 214 seconds. Okay, 45. Speedometer. Accuracy can be affected by many details, blah, blah, blah. For example, variation. Okay, variation. Calibrated 50. So the actual speed minus the expected speed, 50, equals 3. So in this case, this is the speed that's actually being shown on the speedometer. Okay, so x minus 50 equals 3 is the first equation. X minus 50 equals negative 3 is the second equation. So we get x equals 53 and x equals 47. Okay? Now, a speedometer calibrated at 45 miles per hour has an accepted variation of plus or minus 1 mile per hour. What can we conclude from this? That it's calibrated more accurately. We talked about that in class. Okay? It's more accurate, which generally involves more expense. Okay, 47. We're going to make an equation. Okay? Now to make the equation, we're going to take the two numbers and add them together and divide by 2. Okay? So we've got 1.5, as you can see here, going, and negative 1.5. All right? 1.5 plus negative 1.5 is 0. 0 divided by 2 is still 0. Okay, so there is no center number, average number, that is being subtracted from x. And so, and 0, which is the center, is 1.5 from each number. So the margin of error from the average is 1.5. So our equation is simply going to be the absolute value of x equals 1.5. Now, if you wanted to be a stickler about the form, you could say it's the absolute value of x minus 0 equals 1.5. However, it's unconventional to write minus 0, since 0 is the additive identity. Subtracting it or adding it has no change, so it's considered to be trivial, is the term. Okay, 49. We got 0 and we got 1/2. Okay, 0 plus 1/2 is 1/2. Here, let me write that. I kind of skipped this whole thing. 0 plus 0.5 equal, divided by 2 is going to equal 0.25. Okay, so 0.25 is the middle, and it also happens to be the distance from the middle to the, here, where am I? Right here. Okay, 0.25 happens to be the distance from the middle to 0. Okay, so we have 0.25 equals x minus 0.25. 0.25 being the average, and 0.25 being the so-called margin of error. So there's the equation. And we know the two solutions, 0 and 0.5. Okay? 51. Well, here's the graph. Negative 4/3. Okay? So negative 4, here, let me write this like this. Negative 4/3 plus, let's see, 2/3. Okay, divided by 2. It's negative 2/3 divided by 2, which is negative 1/3. Okay? So the center is negative 1/3. Now remember, the form is margin of error. Did I put the form? I don't know. Margin of error equals absolute value of x minus the center, or the average, or whatever. What number are we in? This is 51. Okay. All right. So, but now the center is negative 1/3. Okay. All right. Now, how far is negative 1/3 from the 2 points? Well, it's 3/3, or 1. So here's negative 1/3. So we go 1, 2, 3/3 that way. There's negative 1/3, 1, 2, 3/3 that way. So 1 equals the absolute value of x plus 1/3, because it's the margin of error equals the absolute value of x minus the average, or the center, or the expected, however you want to think about it. All those concepts sort of mean the same thing. Okay? Well, since we're doing a subtraction, here we're subtracting a negative, so we're going to end up with a positive 1/3. Okay. 53. Acoustics. All right. Red Rocks Amphitheater located in Red Rock Park, blah, 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 blah. You can read it. Okay. Such that a maximum of 20,000 people, plus or minus 1,000, can hear natural voices clearly. Okay. A maximum of 20,000 people. All right, so the margin of error, plus or minus, is 1,000 equals x minus 20,000. So what is the find the maximum number of people that can hear natural voices? So it's between 19,000 and 21,000. I mean, I didn't show the solution for this, and I should do that. Okay, 53. So I don't really have any room in here. I did 1,000 equals x minus 20,000. And so I added 20,000 to both sides, and so x equals 21,000. And I did negative 1,000, and negated the left side equals x minus 20,000. Added 20,000 to negative 1,000, and we got x equals 19,000. Sorry about not leaving that in. Okay, let's see. 55. Teams from Washington McKinley High Schools are competing in an academic challenge. A correct response on a question earns 10 points, and an incorrect response loses 10 points. A team earns 0 points on an unattempted question. There are 5 questions in the math section. So what are the maximum and minimum scores a team can earn on the math section? Well, that's simply 50 or negative 50, right? I mean, it's just 5 times 10, or 5 times negative 10. So the max amount is 50 points, 5 times 10, and the minimum points that they can get is 5 times negative 10, because they get negative 10 for an incorrect answer. Okay, suppose the McKinley team has 160 points at the start of the math section. Write and solve an equation that represents the maximum and minimum scores. Okay, so we're going to take this 160 and we're going to treat it like, okay, this is our starting point. So this is another concept that we have for thinking about this model equation. So instead of average, or whatever, or center, well, now we're thinking about it as our starting point. And we're either going to go above this or below this. And the 50 points is the plus or minus. You can either get plus 50 points or minus 50 points at the two extremes. So I got 50 equals the absolute value of x minus 160. So again, I didn't write the two equations. I'll put them in here. 50 equals x minus 160. Add 160 to both sides, and you get x equals 210. Or I get negative 50 equals x minus 160. Add 160 to both sides, and x equals 110. Which makes sense. There should be a 100 number spread since the margin of error is 50. Okay? All right. So that's that, 57. Okay, now we're getting into some quick ones here, but they take a little bit of explaining, so kind of bear with me here. Okay. Determine whether the following statements are sometimes, always, or never true if C is an integer. Explain your reasoning. The value of the absolute value of x plus 1 is greater than 0. Well, no. It could equal 0. If you had the absolute value of negative 1 plus 1, okay, that equals 0. That's absolute, okay? So, it's not always greater than 0. It's only sometimes true, okay? So, but that's the only case that I can think of. That's the only exception. Otherwise, it would always be true, I think. Okay, the solution of the absolute value of x plus c equals 0 is greater than 0. The solution of x plus c, well, no. I mean, we're talking about, okay, c is some integer, right? So, if c was 6, okay, so here we're talking about 59. So the absolute value of plus 6 equals 0. Now when they say solution, they mean x. All right, well, x would have to be negative 6. Okay, so x would be negative. So it would definitely not be bigger than 0. However, if it could be greater, it could be 6 minus 6, c could be negative, and so then x would be greater than 0. So it's sometimes true. Okay? 61. Explain why an absolute value can never be negative. Well, by definition, absolute value is unsigned distance from the origin. Distance has no sign. It can't be negative. Now think about this, okay? You're at you're at Madison, okay? That's 0 north, 0 south, okay? Now you walk to Roosevelt Road, that's 12 blocks. Have you walked negative 12 blocks? No, you've walked 12 blocks, okay? Now, if you walk from Roosevelt Road to North Avenue, you've walked negative, you've covered the 12 blocks between Roosevelt and Madison, and then North Avenue is what, 1600 north, I think. That's 16 blocks north, so that's plus 16 and minus 12. You haven't walked 4 blocks. You've walked 16 plus 12, you walked 28 blocks. Okay, anyway, distance is unsigned. Can't be negative. Okay, 63. Alex and Wesley are solving absolute value of x plus 5 equals negative 3. Now here's good old Alex. Alex is tired. Alex has been doing homework for hours and hours and hours. Alex just says, oh, I just want to get through this problem. He just sits down and he makes the 2 equations. He starts solving them. He comes up with 2 answers. Okay, I'm done. I've got on to the next problem. Wesley, who got enough sleep the night before and didn't spend too much time, he got some rest and everything, maybe even had, did something enjoyable. He sees right away that we got an absolute value all by itself equaling a negative number. Okay? That is the null set. So Wesley is correct. An absolute value, the output from an absolute value, all by itself, on one side of the equation, cannot equal a negative number. Okay, 65, standardized test problem. Okay. Which equation represents the second step of the solution process here? Okay. Here, let me go to the next, because I don't think I have the whole thing here. Here we go. Okay. So, well, the next step, you got 5x plus 20. They're combining like terms, and then they're moving stuff over. So let's see, what's the next step? 8x plus 28 minus 6 equals 3x. Okay, well, that could be that. C is a mistake, 8x plus 7. That's wrong. 4 times 2x plus 1 equals 3x. They subtracted the 6 from the 7. Wow. That's horrible. And A, 4 times 2x minus 6 plus 7 equals, I don't know what happened in A. The only possible answer could be D. So 65, D is the right answer. 67, Tanya makes $5 an hour and a 15-cent commission on a total dollar value in cosmetics she sells. Suppose it's increased to 17%. I don't know. What's the deal with she makes 15 and it's increased to 17? Like, we're not supposed to find the difference. Why do they even bother telling us that? How much money will she make if she sells $300 worth of product and works $30? Well, it's just going to be 0.17 times 300 plus 30 times 5. I mean, really? That's it? That's not much of a problem. Okay. All right, 69. They're just hitting us with this arithmetic here, man. What's going on? Okay, 1/2 of a number increased by 16 is 4 less than 2/3 of the number. 1/2 of the number, x divided by 2, increased by 16 plus 16 is equal sign. 4 less than's, minus 4, 2/3 of the number. X over 2 plus 16 equals 2/3 x minus 4. Okay, the only interesting part of this whole problem. Combine like terms. So I subtract x over 2 from both sides. The common denominator is 6. I get x over 6. I add 4 to both sides. X over 6 equals 20. X equals 120, and I check it, and blah, blah, blah. Okay, 71. If L doesn't show up here, but L must be what goes in that blank spot. If L represents the length of a man's foot in inches, the expression 2L minus 12 can be used to estimate his shoe size. What is the approximate length of a man's foot if he wears a size 8? This perplexing problem just requires you to plug in 8 for at the end of the equation. 2L minus 12 equals 8. 2L equals 20. Add 12 to both sides. Divide both sides by 2. L equals 10. So if your shoe size is 12, the approximate length, I guess, inches is that. 73, 2/5 of a number equals negative 24. 2/5 x equals negative. Really? Come on. X equals negative 16. This is really insulting. 12 is 1/5 of a number. What's the number? 12 equals 1/5 x. Multiply both sides by 5x equals 60. I'm not even checking. That's really, see, I'm not even checking. Okay, that's it.